Right, let's look at measures of centre as part of your stats course. There are 3 measures on the Leave and Cert course. They're called the mean, the mode and the median. And they're called measures of central tendency because they give us a measure of the centre of our data. So the mean is the average, the mode is the value that occurs most often, and the median is the value in the middle once the numbers are in numerical order. So all of them are looking at the most common number or the centre of our data. If we, for example, plotted a histogram, it would give us the most common group within our chart. So let's go through the 3 of them. The mean is a fancy word for average. So you add up all the values and you divide by the number of values. Okay, so the sum of all the values over the number of values. It's often called mu. Mu is a Greek letter, and sigma is also a Greek letter, and it means the sum of. So it's the sum of all the values x divided by n, where n is the number of values. So mu is sigma x over n. And you will find that in your log tables on page 33 at the very top. So mean, very important measure of centre. The mode then is the easiest one. There's no real calculation for it. It's the value or the item that occurs most often. Sometimes there's no mode. Sometimes there's 2 modes, and in that case your data is bimodal. And sometimes there's loads of numbers, and in that case there is no real value that occurs most often, so there's no mode. Median, then you have to arrange your values in ascending or descending. I tend to go ascending order, and then the median is the value in the middle. And if you have an even number of values, what you'll find is there's 2 values in the middle, so it'll be the average of those 2 values. And we'll do an example in all of these which will make them just a little bit more real. So in the median, half of the values lie above the median and half the values lie before. So if you look at the data that comes out every evening on the COVID-19 deaths, you will see quite sadly that often the median age of the people who died on a particular day in Ireland tends to be high. It tends to be 79, it tends to be 80, 82. So when you hear that data, what that means is half the people who died were under the age of 82, half the people who died were over the age of 82. So you can see just from reporting the median age, you can see that actually the people who are dying are quite old, and this is probably because of the nursing home scenario that we have in Ireland. So the median age, listen out for that one when you're listening to how many died from COVID-19. So the mean, the mode and the median. Okay, I'll come back to a measure of spread in a minute, but I just want to do this example down here of the age of the 7 dwarfs. So just on my pad I'm going to redraw that table, and I'm going to do out that example where we will take the measures of centre. So the mean, the mode and the median. Okay. Okay, so we have happy, doc, sleepy, sneezy, dopey, grumpy and bashful. So 685, 702, 498, 539, 402, 685, 619. Okay, let me share this with you now. Okay, So the question asked, I'll just pull up my book here. The question asked, find the mean age. Okay, so mean. So remember, the mean is equal to the sum of the values over the number of values. And you don't really need to write down the formula before it. All divided by 1, 2, 3, 4, 5, 6, 7 values. Okay, so quite simply, you put them into your calculator. Five plus 619 over 7. So I am getting the mean to be 590 years. Okay, so the mean, it's the average. Okay, so then the second measure of center could be the mode, and again you're looking for a value that occurs most often. And actually 685 occurs twice, so the mode is 685. Okay, both happy and grumpy are that age. So the median then, okay, so write the values in order, and I tend to do ascending order. So dopey is first, so 402 is the smallest value there. Then we have sleepy, 498. We have sneezy next at 539. It's the only other 500. Bashful is next, 619. Then we have the two 685s. You must write it down both times. It occurs twice. And then Doc is the oldest, so 702. Okay, so in order then. So what I'm doing is I'm coming in 1, 2, 3 values here. Okay, and then I'm coming in 1, 2, 3 values here. So there's a single value in the middle here, 619. So your median is equal to 619. Okay. So that's the 3 measures of center. I am going to skip the range for the moment. The next question says, when Snow White is included with the 7 dwarfs, their mean age is 518.5 years. Find Snow White's age. So when Snow White is added in, the mean becomes 518.5 years. Okay, so how do we do this? Well, we know that when we add up all of the 7 dwarfs, okay, which we would have got, I'm going to go 590 multiplied by 7 to get all the ages. So I got 4,130 was the ages of the 7 dwarfs, plus X for Snow White. I would divide that by 8. I'm going to get a mean of 518.5. Why divide by 8? Well, there's the 7 dwarfs plus Snow White, so now it's the average of 8 years. Let's bring him up, multiply. Is 4148, and then subtract off 4130. And I got Snow White was 18 years of age. Okay. So just sub in X for whatever value you have and let it equal to the mean. That one comes up a little bit often, so it's good to know how to do it. Okay, so they are measures of centre, and you'll see them coming up quite a bit. We'll come back to them again. I'll be doing it using a calculator soon enough, and I'll show you how to put it into your calculator and so on and so forth. So 3 measures of centre, 3 averages. And I'll come back now to range in 1 second when I do measures of spread. Okay. This table is what I want to do first, and it's when do you use which average. Is one better than the other, so on and so forth. Okay, well, it comes down to your data as to which one is better to use, or whether it makes no difference which one you use. So if your data is very symmetrical, very centered, nice and tidy and neat, then you'll find in many cases that your mean is actually equal to your mode, which is equal to your median. Okay, they all end up being equal to each other. So in other words, let me give you an example where that would be the case. If I asked you for what would be your results in your English exam, okay, of any Leaving Cert year in any year they do the Leaving Cert. Okay, what you'll find is that the results will follow what's called a bell curve. So you will have the majority of people getting 3s in the middle, let that be H3s or H4s or O3s or O4s. And you'll get some getting H5s and H2s, and you'll get even less getting H6s and H1s. Okay, so that's what I mean by quite symmetrical data. So in that data, what you'll find is the mean value for your English result will be very close to your median value, which will be very close to the modal value. Okay, now where they differ is where you have skewed data, and I'm just flicking on to see if I can find a picture of skewed data to show you what I mean. Okay, so that data would be skewed. So you can see the bulk of your data is here, and then it skews off here to the positive values. Okay, or skews right. This data would be a little bit skewed as well, and this data is definitely skewed. Okay, whereas this data here is much more symmetrical. Okay, so it's when your data is not symmetrical that your mean and your mode and your median differs. Okay, so when do you use which one? Well, it's all summarized in this table. So the advantages of the mean, and it's very useful for further analysis. It's always good to get the average. It uses all of your data. We include every single data point in it, and it's easy to calculate. The disadvantage of a mean is it's distorted by extreme results. So where your data tails off either low or high, your mean will be pulled up or down in that direction. A mean is not always a given data value, so it's not a specific value in your data set, it's a calculated value. So it could be fractions, it could be anything. Okay, for example, if we have a look up here when we got 590 for the dwarf's age, you'll see that no dwarf was actually 590. Okay, so it's not a given data value. Mode, well, its biggest advantage is it's very easy to find, you see it. It's not influenced by extreme values. In other words, it's the value that occurs most often. So if you have a value that's very high or very low, it's not going to influence your mode at all. And so it's good with the nominal data and centered data. The mode is not very useful for further analysis. It may not exist, and there can be more than one mode in a piece of data. The median is useful for further analysis. It's unaffected by extremes. Okay, so if you think about the median, okay, so again we'll take the dwarf's ages here. The median is the value in the middle. So if you have a really low value here, can you see it's not really going to have an influence on your median? Okay, it's going to be the first value here, but your median is the value in the middle. So if there's an extremely low or an extremely high value, the median isn't affected. It's easy to calculate if the data is ordered, and it's considered to be a typical value. It's the value in the middle. Again, the median is not always a given data value. That's because if it's an even number, it'll be the average of two values in the middle. It can be difficult to calculate in that it can be difficult to order the data if you have a lot of data. It does not take actual data into account, only its ordered position. Okay, so if you have outliers, that's what we call a really low or really high value, then median is the best measure of center. If your data is fairly symmetrical, it doesn't matter which one you use. The mean is easy to calculate. Okay. So, how does mean, mode and median work if we have a frequency distribution table? So if you remember from junior cert, where we have a body of data like this, we may have to create tallies where we literally put a 4 down here because a 4 occurred. We then go to the 3, we'd put a line here, the 6. So let me just start off that tally table just to make sure everybody can do it. Okay, so a tally table. Okay, so I'm just going to write down that first line of data that was in that example, just to show you how you start off a tally table in case anybody has forgotten. So this is the score on the die, this is the tally, and this is the frequency. One, two, three, 4, 5, and 6. Okay, so what we do is when we get this number 4 here, we just put 1 down in the tally. For this number 3 here, a 1. 2, we've one of them. 6, it's like I'm keeping a count. If anybody is a waitress or a waiter, you'll know what I'm doing because you always tally when you're taking orders. 5, a 6. This is a 1. This is another 1 and a 3. Okay, now I'm going to make up some values here. I'm going to do a 3, a 4, a 3, a 3, a 3. Okay, just to show you what happens then. So I have another 3 here. I have a 4. Then I have another 3, which is my 5th one. So we tend to put a line through it in groups of 5. There's my 6th one. There's my 7th one. Okay, so that's how you tally. And then you add them up. Your frequency is just literally, I have 3 number 1s, I have 2 number 2s, I have 5, 6, 7 number 3s, I have 2 number 4s, I have 1 number 5, and 2 number 6s. Okay, so that's how you would tally. Okay, and then you get your frequency distribution table. So the first part said, show these results on a frequency distribution table. That's what you have here. What conclusions, if any, might the casino owner draw from the results? What further action, if any, might the casino owner take? Okay, so when they're looking for conclusions, they're looking for whether it's a fair die. So do you think that's a fair die? Okay, and I would say there's 2 acceptable answers here. You could say that it was a biased die in that 4 didn't come up often enough. You would have expected more 4s. So you could reject that dice in that it wasn't fair. Okay, and you might ask the casino owner to get a new dice. Okay, the other answer that's equally as acceptable is that 36 isn't a huge number of throws. And you might say if you threw more, if you did the experiment more times, designed experiment more times, then you would expect them all to be roughly the same. Okay, so the action that you might ask the casino owner to take is to throw the dice another 36 times and then have a look at the data. Okay. So that's all fine and well, but how do we get the mean, the mode, the median for discrete or continuous grouped frequency distributions? Okay, so what do I mean by discrete and continuous grouped frequency distributions? Well, if you look at the example that's here, this table up here is what we call continuous grouped data. So 0 to 2. So it can be any value between 0 and 2. We have 5 people. 2 to 6, we have 9 people, so on and so forth. This table here, where we have specific values for time, that's called discrete data. Okay, so sometimes the range of the values is very wide and it's not suitable to show all the values individually. When this happens, we arrange the values into suitable groups called class intervals, such as 0 to 10, 10 to 20, etc. When the information is arranged in class intervals, it is not possible to calculate the exact value of the mean. Okay, that's because you're grouping them or you're putting them into categories. So, however, it's possible to estimate the mean using what's called mid-interval values of each class interval. The easiest way to find the mid-interval value is to add the two extreme values and divide by 2. Okay, so to find the mean of such a table, multiply each value by its corresponding frequencies, sum all the products, divide by the total number of values. Okay, and what you'll see here is that it is a similar formula, and again this is in your log tables on page 33. Instead of being sum of x over n, it's sum of the frequency of each number over the frequency, the total number of numbers. So x is the value of each measurement, or the mid-interval value. F is the frequency of each measurement. So sum of fx is the sum of all the f frequency by each x values, and sum of f is the sum of all the frequencies. Okay, and what it's telling you is that you can use your calculator to calculate the value of the mean mu. Mode, again, you just look at the frequency distribution, and the number with the largest frequency is the mode, or it's the modal interval, it could also be called. Median, as the values are ranged in size, the median can be read directly from a frequency distribution table by looking for the middle value. Okay, so as this one's much more common on your course, let me do this one. Okay. So the frequency distribution below shows the time per week spent watching television by 37 people. Okay, so let me stop sharing for a second so that you get a chance to read that question, and I'll just draw the table. To 12, I have 12 of them. 12 to 20, I have 6 of them. 20 to 30, I have 5 of them. Okay, so estimate the mean time spent watching television. What class interval does the median lie? What's the mode? And what's the range? Okay. So there was a note that 0 to 2 means 0 included, but 2 is not. Okay, and that's important because if there was a value of 2, which category do you put it into, this one or this one? Okay. So, estimate the mean time spent. So, the reason we take mid-interval values is that when we're getting the mean here, which is the average, it's 5 people. But is their time spent watching television 0? Is it 1? Is it 2? So on and so forth. Okay, so the mid-interval value for this first one here is 0 plus 2 and half it, which is 1. 2 to 6 is 4. 6 to 12, so I'm adding the two values. I'm basically getting halfway between the two values. this one is 16, and this one is 25. Okay, so what you tend to do is you can redraw your table, or above your table you can write in your mid-interval values. Okay, so 1, 4, 9, 16, 25. Okay, my mid-interval values. So when you're getting your mean then, and because it's a grouped frequency table, it's f by the x's over the sum of the f's. Okay, so in other words, I have 5 people that watches 1 hour of telly. I have 9 people that watches 4 hours of telly. I have 12 people that watch 9 hours of telly. I have 6 people that watch 16 hours of telly, and I have 5 people that watches 25 hours. It's not over 1, 2, 3, 4, 5. It's over 5 people plus 9 people plus 12 people plus 6 people plus 5 people. Okay, which, as the question told us, is 37. And again, you can put that into your calculator. 5 ones are 5, 9 fours, 12 nines, 6 by 16, 5 25s, all over 37. So the average is coming out there as 10. Okay, so the mean number of hours spent watching television by those 37 people is 10 hours. I'm not overly surprised by it, to be honest, because if you look at the majority of people, can you see that 12 people spend between 6 and 12 hours? So I'm not overly surprised that my mean turns out to be 10. Okay, now in which class interval does the median lie? Well, I have 37. So it's 18 and a half is halfway. So 18 people. So 9 and 5 is 14, 15, 16, 17, 18. So that's going to lie in there as well. Or if I come from the other side, 5 and 6 is 11. And if I add on 18, 29 people. So it's halfway is in here. Okay, so the class interval where the median lies is 6 to 12 hours. Okay, that's where the 19th person would lie. Then it says, what is the modal class? Okay, and again, it's the one with the highest frequency. So again, it's 6 to 12 hours. So you can see this data is fairly symmetrical because my mean, my median, and my mode are all overlapping. Question 4 is range, and I'm going to come on to that in a second. It's my max value minus my min value. Okay, so for a frequency distribution table, the most somebody could be watching telly is 30 hours. The minimum somebody could be watching telly is 0 hours, so my range is 30. Okay, and then the last question said, is the data discrete or continuous? Okay, well, it's continuous data because they could spend any length of time between 0 and 30 hours watching television, not in set steps, but in any value at all. So it's continuous data. Okay, so that's how you work a frequency distribution table. You can, of course, put it into your calculator. So I'll do that now for you. So I'm using a Casio calculator. No, well, actually, I'll leave it on this one because this one can be done by hand, and I'll save the calculator work for a harder example. Okay, let me stop sharing and let's do Okay, so when you're given the mean of a frequency distribution, is it hard to work out? Well, we did example of this where we worked out a particular value in a mean calculation. How do we handle it when it's a frequency distribution table? Okay, so this question says, I've given me a table. If the mean age is 3, find the value of x. Okay, so let me share again, and let's work this one out. Okay, so it's quite algebra based. Okay, so let me draw the table for you. So the table below shows the ages of children in a creche. So 5, 4, 3, 2, and 1. So 4, 7, 9, x, and 5. Okay, so if the mean is 3, find x. Okay, well, you have to know that the mean is the sum of f of x over the sum of f. Okay, so if I was to work that out, I would go 4 times 1 plus 7 times 2 plus 9 times 3 plus x times 4 plus 5 times 5 over 4 plus 7 plus 9 plus x plus 5, and it's equal to 3. So 4 1s are 4, plus 7 2s are 14, plus 9 3s are 27, plus 5 5s are 25. So on the top I'm getting 70 plus 4x. On the bottom I'm getting 4 and 5 is 9, and 9 is 18, and 7 is 25 plus x, and that's equal to 3. Okay, so x appears twice, so we have to do formula manipulation to solve it. Now the first thing I need to do is bring that up on the top so that I have everything on one side, or everything on the top I should say. And then I would bring x's to one side, numbers to the other. And if you solve that, you then get x is equal to 5. So once you know the formula, you just let the formula equal the answer that you were given, and you just work on. Okay. So variability of data, okay, so very important as well. So we had the measures of centre, the mean, the mode, the median. We also have 3 measures of variability, or measures of spread. Okay, on your course it's the range, which is max value minus min value. We have the interquartile range, and we have standard deviation. So the range is based on the extreme values of the distribution. It's the highest value minus the lowest value. Interquartile range is where you break your data into quarters, and it's the third quarter minus the first quarter. You've already broken the data into half to find Q2, where Q2 is actually your median. So instead of just breaking it into half, you break it into quarters. So you still have to arrange your data in ascending order, and then we just quarter it. So we'll come back to that one. But for now, let's look at standard deviation. So this is called sigma, another Greek letter, sigma, and it is the most important and useful measure of spread, and it's an awful lot what inferential statistics is based on. It gives a measure of the deviations from the mean, and is calculated using all the values in the distribution. So standard deviation is like, if you think of the range, right? It just uses the max value and the min value. So no matter how many data points you have, the range only considers two values. Interquartile range is similar. It still only uses very, very little of your values. Okay, it's the third quarter value minus the first quarter value. Standard deviation is liked because it takes every single value and it compares it to the mean mu. So, and it's quite a long calculation, so the formula is down here. So for each reading x, you calculate x minus mu. In other words, you see how far is each reading from the standard deviation. So because these values could be plus or minus depending on whether they're to the left or the right of the mean, you may get a minus answer. Now, we don't want the minus and the plus deviations to cancel each other, so what we do is we square all of the deviations, because when you square a number it becomes positive. Okay, so we take each of the deviations and we square them. We then sum them. We add up all the little deviations, each value, how far is it away from the mean, we sum up all of those deviations, and then we find the average. So in other words, we divide it by n, the number of numbers. And then because we squared it, we need to square root it again to get back to a meaningful value as to how far the standard deviation or the average deviation from the mean is of all that data. Okay, so I'd like to do an example of this for you by hand, just one. Again, we will do this with a calculator in general, but I think it's worth doing one value or one example to show you how do you calculate standard deviation. Okay, so let's take, what one will we take? Let's take 12, because it's just a bit oddbally. The array of numbers 1, 2, 4, 5, 8, 16 has a mean, mu, and a standard deviation. I'll just call that SD for short. Okay, so 1, 2, 4, 5, 8 and 16, and we want to verify that mu minus sigma is 1. Okay, let's share. Okay, so the easiest way to do this tends to be in a table. So let's write down my x values first, which are 1, 2, 4, 5, 8, and 16. So 1, 2, 4, 5, 8 and 16. Okay, so the next thing we do is we go x minus mu. Okay, do I know what my standard or what my mean is mu? No, not yet, so I need to calculate mu my mean. Okay, so let's do that up here. It's 1 plus 2 plus 4 plus 5 plus 8 plus 16 divided by 1, 2, 3, 4, 5, 6 numbers. So let's do that. So 1 and 2 is 3 and 4 and 5 and 8 and 16 divided by 6. So my mean is 6. Okay, so all of these then is x minus u, so it's 1 minus 6, so I'm getting minus 5. This one is 2 minus 6, I'm getting minus 4. 4 minus 6, getting minus 2. 5 minus 6, minus 1. 8 minus 6 is 2. 16 minus 6 is 10. Now you see, if I didn't square them, that minus 2 would cancel with this 2, and our spread of our data would look better than it was, because some of the answers would cancel each other. but that we don't want that because both 4 and 8 are a distance of 2 from my mean. So we want to capture that spread in our data, not have it cancel each other out. Okay, so that is why we have to square our data so that that doesn't happen. So minus 5 squared, 5 5s are 25, 16, 4, 1, 4, and 10 squared is 100. Okay, we then have to sum them up. Okay, so add all of them up. So we've 100 plus 489 plus 16 plus 25, so it's 150. Okay, so that's that top line there done now. My next bit is I need to divide it by n. So it's 150 divided by n, which is the number of numbers, which is 6. And I've got 25 for that. And then the last job is to square root it. Square root of 25, which is 5. So you have worked out that your standard deviation sigma is 5. Okay, so not overly difficult, just tedious, very tedious to do by hand. Okay, so the question then asked to show that mu minus sigma was equal to 1. Well, yes, we do have that my mu was 6 minus my standard deviation, which was 5. So it is indeed equal to 1, and that's it proven, QED. Okay, that's standard deviation by hand. So from now on, I would recommend you practice one of them. Doesn't really matter what one, perhaps 13, it's similar, or 14, it doesn't really matter. Just practice it by one, because from here on in, I am going to do it by hand. Okay, so that's standard deviation. Okay, so you will also need to do standard deviation, or could be asked to do standard deviation of a frequency distribution table. Okay, not overly different. I'm going to bring you down here to this example. So 50 boxes of matches were taken and a record made of the number of matches per box. So 47, 48, 49, 50, 51, and we have a number of matches per box there. Find the mean, estimate that are between, I'll come back to that, and find the standard deviation. So it's the standard deviation one that I want to look at. So that's the frequency. You can see your 6, your 9, your 18, your 13, and your 4. So this bit should be the same. That's your x values. Okay, so you take your x values and you subtract your mean from it. So you've worked out your mean is 49 and you're getting minus 2 squared. Okay, so you again, just like before, x minus mu all to be squared. Okay, and then what you do is you take your frequency f and you multiply it by x minus mu squared. So it's 6 times 4 to give me 24. So if you have a look at the formula, there's a little extra f up here. Okay, 9 times 1 is 9, 18 times 0 is 0, 13 times 1 is 13, 4 times 16, and then you add them all up to get 62, and you divide by the sum of the frequencies. So 62 divided by 50, we had 50 matches, and you square root it, so your standard deviation is 1.11. Okay, so there was an extra column here that I wouldn't have had in if I was just calculating standard deviation, which is fx. The reason it's here in this example is to calculate the mean. So they're using the table here to calculate both the mean. So there's your 2450 divided by 50 to get your mean of 49. They're using the table to calculate both the mean and their standard deviation by hand. So it's not overly difficult. Just practice one in an exam paper, and again I'll be giving you this in due course so that you're familiar with it. Okay, I'm going to leave it at that. I did skip empirical rule, and I'm going to come back to the empirical rule when I'm doing, where's my empirical rule gone? Here, it's only a little bit down here. I'm going to do the empirical rule again when I am looking at normal distributions. Okay, thank you.